First problem here, inverse sine of the negative square root of 2 over 2. Now, recall that inverse sine is defined between negative pi over 2 and pi over 2. So that's where you want your answers to come from. If it's not a quadrantal angle, it comes from one of these two quadrants. If you take the inverse sine of something that's positive, that's the answer from the first quadrant. If you take the inverse sine of something that's negative, you want the answer from the fourth quadrant. For inverse sine, to get the answer in the fourth quadrant, in between negative pi over 2 and 0, find the one in the first quadrant, and then make your answer negative, or make your angle measure negative. That'll put it in the fourth quadrant. That works for inverse sine because of the even-odd properties. So the sine of what is a positive square root of 2 over 2 in the first quadrant would be pi over 4. So make that angle measure negative, so your answer is negative pi over 4. Alright, the second problem, the inverse cosine of negative square root of 2 over 2. So recall where inverse cosine is defined. It's defined between 0 and pi. It can also be an endpoint. So if we take the inverse cosine of something that's positive, we want the angle measured from the first quadrant. If we take the inverse cosine of something that's negative, we want the angle from the second quadrant. So this is the inverse cosine of something that's negative, so I want the angle measure in the second quadrant. So I have to say, okay, what would the angle measure in the first quadrant be? The cosine of pi over 4 is the square root of 2 over 2. That's my reference angle. To get pi over 4's multiple in the second quadrant, you say pi minus the reference angle. So my answer is going to be pi minus pi over 4. So that's 1 pi minus 1/4 pi, or 3/4 pi, or 3 pi over 4. The next problem is the inverse tangent of 0. So inverse tangent is defined similarly to inverse sine. It's defined between negative pi over 2 and pi over 2. Tangent is equal to 0 in between negative pi over 2 and pi over 2 at one place. If we take the tangent of 0, we get 0. So that means the inverse tangent of 0 is equal to 0. It's a quadrantal angle. Alright. Number 4 is the inverse sine of the sine of 6 pi over 7. So if the inverse is on the outside and it's the same function, just the inverse of the regular function, then we want to look at this right here. If this angle measure is between negative pi over 2 and pi over 2, then the answer is just equal to the angle measure. If it's not in between negative pi over 2 and pi over 2. Then we need to figure out the positive or negative sign that it would have and change it over to its multiple in the fourth quadrant or the first quadrant. So this right here, this 6 pi over 7, this is not between negative pi over 2 and pi over 2. So this angle measure is not in the fourth or first quadrant. So we need to figure out where it is. If this is 1 pi, this is 6/7 pi. So we're right here. In the second quadrant, sine is positive. Inverse sine is defined between negative pi over 2 and pi over 2. Sine is positive in the first quadrant. So we want to take this angle in the second quadrant and change it over to its reference angle. The way we do that is we use the formula pi minus theta. So we want to solve for the reference angle so that we can get the angle measure in the first quadrant. So we say pi minus theta equals 6 pi over 7. And solve for theta. So I'd subtract pi from both sides. So I have negative theta equals, this is 6 pi over 7 minus 1 pi. So 6 pi over 7 minus 7 pi over 7. So negative theta equals negative 1 pi over 7. Divide both sides by negative 1. So I get theta equals positive pi over 7. That's the reference angle. That's the angle in the first quadrant. That's what I want to change it to. So the inverse sine of the sine of 6 pi over 7 is the same thing as the inverse sine of the sine of pi over 7. And now that that's between negative pi over 2 and pi over 2, the answer is just pi over 7. Alright. Number 5, the inverse cosine of the cosine of 3 pi over 5. So when we have the same function, except one of them is inverse, and that one's on the outside, and on the inside is the regular function. It's cosine. If this angle measure right here is where inverse cosine is defined, then it's going to be our answer. Inverse cosine is defined between 0 and pi. So is 3 pi over 5 between 0 and pi? Yes, it is. So that means my answer is 3 pi over 5. Since it's between 0 and pi, because that's where inverse cosine is defined. Alright, number 6, the sine of the inverse sine of negative 0.6. So, same function, one is the inverse, and this time the inverse is on the inside. When the inverse is on the inside, then whatever we're taking the inverse of, for sine, or inverse sine needs to be between negative 1 and 1. If this is between negative 1 and 1, which it is, then the answer is just what I was evaluating. So the answer is negative 0.6. That's because the inverse is on the inside. Okay. Number 7, the secant of the inverse sine of negative square root of 3 over 2. So, since I have different functions here, I have a secant here and an inverse sine here. There are a couple ways you can work this problem. The way that will always work is by using x, y, and r. And that's the way I suggest to work these next few problems. So the way that I work this using x, y, and r is I say if I want to know the inverse sine of negative square root of 3 over 2, then that means that the sine of some angle measure is equal to negative square root of 3 over 2. And sine in terms of x, y, and r is y over r. So if I know that sine is y over r, where y is the y coordinate, r is the radius, then the negative here in front has to go with the y because a radius can't be negative. So I have y equals negative square root of 3 and r equals a positive 2. Now I want to know the secant of whatever that is inside. So recall that secant in terms of x, y, and r is r divided by x. So since secant is r divided by x, I'm going to have to find the x value to solve this problem. So I use the equation x squared plus y squared equals r squared to solve for x. Now we need to be careful with the positive or negative sign for x, and we'll come back to that when I solve for x. Let's go ahead and plug in the y, plug in the r. So I'll have x squared plus negative square root of 3 squared equals 2 squared. So x squared plus 3 equals 4. Alright, so solve for x, subtract 3 from both sides. So I get x squared equals 1. Alright, now, solve for x, you take the square root of both sides, get x equals plus or minus 1. And to tell if it's positive or negative, you go back and you look at the inside here where we have the inverse. And since we're taking the inverse sine, this angle measure has to be between negative pi over 2 and pi over 2. Since it's a negative, it's going to be the angle in the fourth quadrant. Because you're taking the inverse sine of a negative, it's going to be in the fourth quadrant. In the fourth quadrant, our x values are negative, our y values are positive. So if you have to solve for y, make sure it's, if you have to solve for x, make sure it's positive. I think I said that backwards. Your x values are positive, your y values are negative. So if you have to solve for x, make sure you make it positive. If you have to solve for y, make it negative. Well, we were already given the y was negative square root of 3. So when we solve for x, we want to make it positive. So x is going to be a positive 1. Secant is r over x. So secant is r, or 2, divided by x, which is 1. 2 divided by 1 is 2. So your answer is 2. Alright, next problem. The cosine of the inverse sine of 1/2. Alright, so what this means is the sine of something is equal to 1/2. That something happens to be in the first quadrant because when you take the inverse sine of a positive, you want the answer from the first quadrant. So if we do have to solve for x, y, and r, since we're in the first quadrant, make sure your x's are positive and your y's are positive. Okay, so sine is equal to y over r. So that means y equals 1, r equals 2. We want to find the cosine of whatever that angle measure is. Remember, cosine is x over r. So I need to solve for x. I have y, I have r, so I can solve for x. So I have x squared plus 1 equals 4. So x squared equals 3. Or x equals plus or minus the square root of 3. Since we're in the first quadrant, it's going to be a positive square root of 3. Alright, so the cosine is x over r. X was square root of 3. R was 2. So the answer is a positive square root of 3 over 2. Alright, number 9. The tangent of the inverse cosine of negative 1/2. So that inside means that the cosine of some angle measure is equal to negative 1/2. And cosine is x over r. So that's going to be negative 1 for x, positive 2 for r. Now recall where inverse cosine is defined. It's defined between 0 and pi. When you take the inverse cosine of something that's negative, you want the angle measure in the second quadrant because that's where cosine is negative. Alright, so the angle measure is here. If the angle measure is here, we need to make sure that all of our y's are positive, all of our x's are negative. So our x was negative 1. When we solve for our y, if we have to solve for our y, we need to make sure we make it positive. Alright, we want the tangent of the angle measure. Tangent is y divided by x. So we do need to solve for y. So use the equation x squared plus y squared equals r squared. So that's going to be negative 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. So y squared equals 3. So y is equal to plus or minus the square root of 3. Since we're in the second quadrant, we want the positive. So we want y equals positive square root of 3. Alright, so tangent is going to be equal to a positive square root of 3 divided by a negative 1. That's going to be negative square root of 3. Alright. Number 10 is the inverse cotangent of square root of 3 over 3. Now, inverse cotangent is the only reciprocal that's not defined, the only reciprocal trig function that's not defined like its reciprocal. Remember, tangent and cotangent are reciprocals of each other. But inverse cotangent is not defined like inverse tangent, unlike the other reciprocals. Inverse cotangent is defined between 0 and pi. Alright, so if I take the inverse cotangent, I want to get the answer, and it's positive, I want to get the answer from the first quadrant. So make sure, no matter which trig function you use, that you get the answer from the first quadrant. Why I say that is because generally, if we're evaluating reciprocals, we would use its reciprocal. We would use inverse tangent to find this answer, because usually you don't remember all the answers for inverse cotangent. But inverse tangent is a little bit easier to remember, or tangent's easier to remember than cotangent. Alright, so if you do use this function, just make sure, the inverse tangent function, make sure you get the answer from the first quadrant. So if you use inverse tangent, then you have to take the reciprocal. So that would be 3 over the square root of 3. You work that out and simplify. That would be 3, this would be the inverse tangent of 3 square roots of 3 over 3, or just the square root of 3. Because this 3 up here will cancel out the 3 you get down there. Alright, so if we get this answer and make sure it's from the first quadrant, that will be the answer for the inverse cotangent. Alright, so it's either going to be pi over 3 or pi over 6. The way that I think about tangent is sine divided by cosine. So if it was the sine of pi over 3, that would be square root of 3 over 3, over the cosine of pi over 3, that would be 1/2. Square root of 3 over 2 divided by 1/2 is what? Square root of 3. Right? Right? Square root of 3 over 2 divided by 1/2. If that was sine of pi over 3 and that was cosine of pi over 3, if you flip and multiply, you got square root of 3. So what that means is the inverse tangent of square root of 3 is pi over 3. So if the inverse tangent of square root of 3 is pi over 3, and that's in the first quadrant, then the inverse cotangent of square root of 3 over 3 is also pi over 3. Alright, number 11, the inverse secant of 2. Luckily, inverse secant is defined like its reciprocal, except maybe at one point where it's undefined. So it's really easy to use its reciprocal function, inverse cosine. If we use inverse cosine, we have to take the reciprocal of 2, which is 1/2. So the inverse cosine of a positive means we want the answer from the first quadrant. So you just say to yourself, the cosine of what is 1/2? Pi over 3. So that means that the inverse secant of 2 is also pi over 3. Number 12 is 2 cosine theta plus 3 equals 2. And the directions say that theta needs to be between 0, greater than or equal to 0, less than 2 pi. Now remember, we don't use the same rules when we solve trig equations as we do with inverses. Because when we solve this equation, we're going to solve for cosine. And it's not going to be inverse cosine of something, it's going to be the cosine. And so depending on whatever I get over here on the right side, if it's positive, then I want my multiples from the two places where cosine is positive. Or I want my angle measures from the two places where cosine is positive. If I work it out and I have cosine theta equals a negative something, well, cosine is negative in two places, two quadrants. So I want both of those answers. Alright, here's what I'm talking about. To solve this, we need to get cosine by itself. So this is 2 cosine theta equals negative 1. Divide both sides by 2. I get cosine of theta equals negative 1/2. So I say to myself, where is cosine equal to a negative 1/2? If we use our salty C chart, this tells us that cosine is positive in the fourth and positive in the first quadrants. It's negative in the second and third quadrants. So for me to take the cosine of something and get a negative, the angle measure has to be in the second or third quadrant. So I want the angle measure in the second and third quadrants. To do that, you figure the reference angle out and then say pi minus the reference angle to get its multiple in the second quadrant and pi plus the angle measure to get its multiple in the third quadrant. It all depends on finding the reference angle and using the right formula. Alright, so the cosine of pi over 3 is a positive 1/2. That would be the reference angle from the first quadrant. To get the answer in the second quadrant, I'll say pi minus pi over 2. So that's 1 minus 1/2. 1 pi minus 1/2 pi is 1/2 pi. Okay, is that right? It's pi over 3, isn't it? Not pi over 2. So what would that be? Pi minus pi over 3 is 1 pi minus 1/3 pi is what? 2 pi over 3. How do I get its multiple in the third quadrant? Pi plus pi over 3. Right? That's the formula. Pi plus theta. So 1 pi plus 1/3 pi. That's 4/3 pi. Or 4 pi over 3. So your two answers here, 2 pi over 3 and 4 pi over 3. Alright, 2 cosine squared theta minus 3 cosine theta plus 1 equals 0. Alright, so this is a quadratic. So we need to factor it like we would a quadratic. So this first factor starts out 2 cosine theta. The next factor starts out cosine theta. Then I have to use the factors of a positive 1. Now when I multiply the factors together, I want to get positive 1. So either it's a positive 1 and a positive 1 or a negative 1 and a negative 1. Look at the middle term though, it's negative. So what that tells you is these both have to be negative 1. Now if you multiply the outer terms together and the inner terms together and add them together, you should get a negative 3 cosine theta, and you do. So that means that's factored correctly. So set each factor equal to 0. and solve each equation. So I have 2 cosine theta equals 1. So cosine theta equals 1/2. And my other equation is cosine theta equals 1. Alright, so I want the two places where cosine is equal to a positive 1/2. That's going to be the first quadrant and the fourth quadrant. So we're equal to a positive 1/2 in the first quadrant at pi over 3. To get its multiple in the fourth quadrant, I say 2 pi minus the reference angle. So 2 pi minus pi over 3. So you probably want to think about that like that. 6 pi over 3 minus 1 pi over 3. It's going to be 5 pi over 3. So my two answers are, for this first problem here, pi over 3 and 5 pi over 3. Alright, now cosine theta equals 1. Well, that's quadrantal angle. Cosine is equal to 1 only at one place. The cosine of 0 equals 1. So that's the quadrantal angle 0. So my solution set is 0, pi over 3, and 5 pi over 3. Alright, number 14. Cosine of theta minus sine of theta equals 0. So I have a trig function to the first power and another trig function to the first power. This one is kind of tricky. The way that you work it out is you set the two trig functions equal. So move one over. You always do this if you have two trig functions and they're both to the first power. So I'll have cosine theta equals sine theta. Then, this is the step where a lot of students get lost or don't know what to do. We want to get a number on one side. The way that we would do that is dividing both sides by cosine or dividing both sides by sine. I'm going to divide both sides by sine. So I would have cosine over sine, probably not the best one, but cotangent still works, equals 1. Well, cotangent is equal to 1 at two places. Cotangent is positive in the first quadrant and, like its reciprocal, positive in the third quadrant. If you use the tangent function, you take the reciprocal of 1, that's still 1, right? So you can think about this like tangent of theta equals 1 as well. It's the same answers. So what angle measure in the first quadrant, when you take the tangent or the cotangent of, do you get 1? Pi over 4. So that's one of our answers. To get our other answer, we want the multiple in the third quadrant. That's pi plus theta. So pi plus pi over 4. So that's 1 pi over 4 plus 1/4 pi, or 5/4 pi. Which you can also think of as 5 pi over 4. Alright, number 15. 1 minus sine theta equals 1/2. Alright, to get sine of theta by itself, I'd first move the 1 over. So you have negative sine theta equals 1/2 minus 1 is negative 1/2. But we don't want negative sine theta, we want sine theta. So we have to divide both sides by negative 1. So I'd have sine of theta is equal to a positive 1/2. So we have to say, okay, where is sine positive 1/2? Sine is positive in the first quadrant and in the second quadrant. In the first quadrant, the sine of pi over 6 is a positive 1/2. Then to find its multiple in the second quadrant, you say pi minus theta. So pi minus pi over 6. So that's 1 pi minus 1/6 pi. That's going to be 5 pi over 6. So my two answers are pi over 6 and 5 pi over 6. Alright, number 16. Tangent squared theta equals 3. Well, just like if this was x squared equals 3, I'd have to take the square root of both sides. It gives me the tangent of theta equals plus or minus the square root of 3. We put a plus or minus in front and we take the square root of both sides. Even though if it's a trig function there, you do the same thing. So that means we want the answers from all four quadrants. The two places where tangent are positive, square root of 3, and the two places where tangent are negative, square root of 3. So if we can figure out the place in the first quadrant, then we can find the others by saying pi minus theta, pi plus theta, and 2 pi minus theta. So in the first quadrant, that's going to be pi over 3. So to find the multiples, we say pi minus pi over 3. I'm going to go ahead and write down my first answer, pi over 3. Pi minus pi over 3 is 2 pi over 3. Pi plus pi over 3 is 4 pi over 3. And 2 pi minus pi over 3 is 5 pi over 3. So those four answers for number 16. Number 17, the tangent of 2 theta equals negative 1. So what I want to do is I want to write down first the general formula where the tangent of theta would equal to negative 1. So I have to say, okay, where is tangent negative? It's going to be the second and fourth quadrants. And so if I get it, the angle measures multiple, the reference angle's multiple in those two quadrants, that's what I'm going to use in my general formulas. So remember, the tangent of pi over 4 is a positive 1. So that's the reference angle. So in the second quadrant, that's pi minus pi over 4. That's 3 pi over 4. In the fourth quadrant, that's 2 pi minus pi over 4. So that's 7 pi over 4. Since this is tangent, the way we do the general formula is we put plus k pi, because tangent repeats every pi. Once we have the general formula set up, then this is not just theta, this is 2 theta. So we'll put a 2 in front there, and now solve for theta. So you divide everything by 2. So I'm going to have theta equals 3 pi over 8 plus k pi over 2. and theta equals 7 pi over 8 plus k pi over 2. Now I start letting k equal integers to get my answers between 0 and 2 pi. So I'd start out k equals negative 1. If you do, you're going to have 3 pi over 8 minus pi over 2. That's going to be a negative pi over 8. Maybe more than that, a negative 5 pi over 8. Then if I let k equal negative 1 there, I'm going to get a negative pi over 8. So those two answers are less than 0, so they're not included. Now step k up and let k equal 0. So if k is 0, you get 3 pi over 8 and 7 pi over 8. So that's two of your answers for sure. If k equals 1, you have 3 pi over 8 plus pi over 2 and 7 pi over 8 plus pi over 2. That's going to give you, let's see, that's going to give you 11 pi over 8 for the second one. It's going to repeat an answer for the first one. So if you repeat an answer, you don't take the answer twice. You just take it once. Repeat this process over and over, and eventually your last answer you'll get is 15 pi over 8. You just let k equal 2, and you'll get that. So your three answers here are 15 pi over 8, 11 pi over 8, 7 pi over 8, and problem number 18, 2 sine squared minus 3 sine minus 2 equals 0. So again, this looks like a quadratic. So you want to factor it just like you would a quadratic equation. And it is a trinomial. It's 3 terms. So I want to start out 2 sine theta and sine theta. Alright, now the factors that or the numbers we want to put in here and here need to come from negative 2. We need to be careful because when we multiply it out, we want to get a negative 3 sign in the middle. So this is going to be minus 2 here plus 1 here, and let's check and make sure. So if we multiply 2 sine theta times negative 2, that will be negative 4 sine theta. And if we multiply positive 1 times sine theta, that will be plus 1 sine theta. And so that gives us negative 3 sine theta, which is my middle term. So that means that's factored correctly. So now we can set each factor equal to 0 and solve. Alright, so I'm going to subtract 1 from both sides. I get 2 sine theta equals negative 1. Divide both sides by 2. Get sine of theta equals negative 1/2. So I need to figure out the two places where sine of theta, or what angle measure could I plug in here and get a negative 1/2 out whenever I take the sine. Alright, sine is positive in the first quadrant and the second quadrant. It's negative in the third quadrant and fourth quadrant. So that's where I want my answers. The answer from the third and from the fourth. In the first quadrant, the sine of a positive pi over 6 would give me positive 1/2. The reason I need that, I need the reference angle so that I can find its multiple in the third and fourth quadrants. In the third quadrant, I say pi plus pi over 6. The two answers I get, that'll be 7 pi over 6. And that'll be, so in the fourth quadrant, it's 2 pi minus the reference angle. So we'll have 2 pi minus pi over 6, and that's going to be 11 pi over 6. Alright, now our other equation is sine of theta minus 2 equals 0. So add 2 to both sides. So I get sine of theta equals a positive 2. You can't take the sine of something and get 2. Because every answer you get out when you take the sine has to be between or including negative 1 and 1. So that means there's nothing from this factor. So my only two answers are 7 pi over 6 and 11 pi over 6. And you could, on this side here, you could say no solution if you want to. Alright, because you can't get any answers there. Number 19, right away I see I have a squared term and I have a term to the first power, so I may be thinking factor. But then I notice that my trig functions are different. I have a sine squared and a cosine to the first. Anytime your trig functions are different and one of them is squared and one of them is to the first, you need to use a Pythagorean identity. So the Pythagorean identity we will use is sine squared theta plus cosine squared theta equals 1. And the reason we have to use this one is, to solve this, I'm going to need either all sine terms or all cosine terms. So I can't change cosine over to sine easily. But I can change sine squared over to cosine squared easily by using this identity. And the way that you would use it is you get the sine squared term by itself. So subtract cosine squared from both sides, and you'll have sine squared theta equals 1 minus cosine squared theta. And so what I can do now is I can take that 1 minus cosine squared and plug it in parentheses for sine squared. So now my equation becomes 2 times 1 minus cosine squared theta equals 3 times cosine theta plus 1. So let's multiply everything out. I would have 2 minus 2 cosine squared theta equals 3 cosine theta plus 3. Now, to make this easier to factor, I want to get the cosine squared on one side, and I want to make it positive. So I'm going to have to move all of the terms to one side, and I want the cosine squared term to be positive to help me factor easily. So I'll just take these two terms that are on the left side, and I'll move them to the right side. So I'll say minus 2 and plus 2 cosine squared on both sides. Let's say minus 2 plus 2 cosine squared. So I'm setting this thing equal to 0. Now I will have 3 cosine theta plus 1 plus 2 cosine squared theta. You want to rearrange these terms so that you have your highest power first. So we're going to have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Alright, so now we want to factor. This will be 2 cosine theta and cosine theta. Breaking that up. Now use the factors of 1, so it's going to be plus 1 and plus 1. And then make sure you get a 3 cosine theta in the middle. So multiply the outer terms. That will give you 2 cosine theta. Multiply the inner terms. That will give you 1 cosine theta. And 1 plus 2 is 3 cosine theta. Okay? And that's equal to 0. So set each factor equal to 0 now. And solve. It's called the zero product principle. Alright, and so solve for cosine in both equations. So we have 2 cosine theta equals negative 1. Divide both sides by 2. So our first equation is cosine theta equals negative 1/2. The two places that would give you a negative 1/2 are the angle measures from the second and third quadrants. The one from the first quadrant, where cosine will be a positive 1/2, the reference angle, is pi over 3. To get the angle in the second quadrant, that's pi minus pi over 3. So that's 2 pi over 3. The way that we get the answer from the third quadrant is we say pi plus theta. So pi plus pi over 3 is 4 pi over 3. So that's 2 of your answers. Now we have this equation to solve. So if you move the 1 over, you'd have cosine theta equals -1. Well, cosine is equal to -1 only one time. That's a quadrantal angle. The cosine of pi is -1. So your third answer here is just pi. So those are the 3 answers. That's your solution set. Number 20, we have another one of these problems where we have a trig function and another trig function, but they're both to the first power. The way you want to treat that, if you ever have 2 trig functions and that's it, they're both to the first power, you want to set them equal. Well, luckily these are already set equal. Now, we want to get a number on one side, so you want to either divide both sides by secant or divide both sides by cosine. So let's see what happens when I do that. Alright, I'm going to divide both sides by secant. Alright, so I'm going to divide both sides by secant, and I will get 1 equals cosine theta over secant theta. Now, this isn't simplified. What does secant become if I move it to the top? Remember, with trig functions, I don't change the power. If I take the secant and move it to the top, it becomes cosine. So this will be 1 equals cosine theta times cosine theta. Or cosine squared theta equals 1. Take the square root of both sides, and I get cosine theta equals plus or minus the square root of 1, or plus or minus 1. Well, those are quadrantal angles. Cosine is equal to 1, -1, and 0 at quadrantal angles. So what are the 2 quadrantal angles? The cosine of what is positive 1? Well, that's 0. The cosine of 0 is positive 1. The cosine of what is -1? That's pi. Cosine of pi is -1. So those are my 2 answers.